here.
Yeah, times in a row, me and Igor, I think, was with a pause.
Yeah, it's a nice tradition. Yeah, again, we are here to entertain you in this early morning, if you're in Europe, of course. Yeah, and so again, just a couple of words about XTechnology. So we are people who get together and want to learn more about different technologies, programming, data science, education around IT, maybe a bit of soft skills and so on. And we're running some projects. So some of these projects found on our, please visit our super website, xtechnology.dev or .dev. So we have some projects, we have also some workshops. Sometimes we do so-called code hours, so that's what we're gonna do today. It means that we are here for an hour and we're gonna do some hopefully exciting and cool stuff. So today the topic of our code hour with Python. So again, this is episode number 3. Alex will give a couple of tasks on LeetCode and I'll try to solve them. Let's see how it goes. Like I think the first 2 iterations were kind of okay. I think the second was better than the first, of course. Yeah. As far as I remember, I didn't manage to solve both of the tasks that Alex gave to me, but let's see what's in here today. And well, yeah.
Yeah,
We could start, I guess.
noise environment right now. I prepared indeed some tasks and actually sort. You don't need to know tradition, but you can think of on something during the exercise. That's one. The other to say.
Yeah. Sorry, I think I missed a couple of words that you've been saying, but yeah. But I got the link. Let me copy the link and let's go into here. Better. I'm mistaken because they have similar names for different tasks. And it takes just around 20 seconds to load the web page. Modern world.
This now is it a little better?
It's okay, yeah. Well, yeah, see, I kind of solved it, but well, let me copy this stuff to someone else just as I have a solution, and so then I just dump this and dump
Okay.
this.
So that's not a problem.
Set it before.
I have another one. Yeah, close to
Okay,
that one, maybe.
okay, okay.
Yeah.
Let's try this one. Another 20 seconds. Just woke up. It's Saturday. So this one I also did solve, but I mean I can just the code and we go through it. If we have more, we can try more. So what did you say?
You saw your tasks recently, right?
Sorry? Sorry?
You've been recently, so this is you already
I think I did them like
done.
last 2 months. Yeah, this I done maybe 2 months ago
Okay.
or months ago. But we can actually maybe practice because I think maybe go to the previous one because I think I did it like 3 months ago and I probably don't remember how to do it properly. Maybe I do.
Yeah, sounds good.
Silence. What do you think?
Yeah.
Cool. cool. Let's wait another 20 seconds. Yeah. Okay, I will dump the stuff. Yeah. Okay. So let's do it. Given an n by n to the binary grid, which represents a map of in the land where 0 is water, return the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. Okay, and they give an example in here. So basically, let me copy it here. So it's kind of a map. So one is a land, 0 is a water, and here, for example, we have
Can you
one
make
island.
it a little bit bigger, please?
Oh yeah, you're right. I forgot. Oh, by the way, now I hear you perfectly.
Yeah, thanks. Thanks to my other garniture. Yeah.
Yeah, so now it's bigger. So yeah, on this image, I guess the island, there's only one island. Yeah, because all these ones, they are kind of connected. Oh, yeah, I can't highlight them all, but they are kind of connected into one big island. So there are no drops. And in this example, yeah, if I copy it in here, oops. Yeah, almost. So in this example, yeah, we see that this and this, yeah, I cannot do it. So these 4 ones are one island, and this small tiny thing one is another island, and these 2 guys form the 3rd island. So there are 3 islands in this structure. Okay. Let's think how to do it. So yeah, so I think in general the approach will be iterating through every element of this 2D array. And then if we find out that this is the land, so the one, so let me maybe write it in pseudocode. So iterate through the array. If it's a land, then we start traversing the land. So meaning that if we find that it's a land, we start going from this land to all the sides, and so we explore this how it's called, breadth first search. So we go to all possible sites. We see if there is land, then we go again to all possible sites from this place, and we do it until we explore the whole island. So it's kind of like if you're a person, you're stuck on the small piece of island, and then you start going in all directions until you reach the shores of the island. So it's getting bigger and bigger, and in the end, you know that all the elements of the island. And so we start traversing the island, and also we have to keep track of the elements we already visited. So meaning that we don't have to traverse the same elements twice, because otherwise our program will run for an enormous amount of time. It means that if we already been here, we have to save the element to some hash and already get the value from the hash. And when we finish this iteration, we will know the amount of islands. Yeah. Okay. So we start traversing the island, and when we finish, we update the number of islands. Okay, yeah, so let's start coding it, I guess. Oh, yeah, maybe I forgot some small things. So what's important here to do as well?
I mean, performance-wise, we can always make an optimization afterwards, I guess.
Yeah.
Side question, HackerRank is a resource you haven't touched yet, right?
I think I did like maybe 10 to 20 tasks there.
Okay.
Yeah, but I usually do LeetCode, yeah. But HackerRank, only a couple of them. Yeah. So yeah, I don't know. Like even like for example, some edge cases in here. I don't really see edge cases because we always so the size of the grid is always at least one. So there's no need to do something for empty grid. Yeah. I don't know. I think I could start coding and then we see where it gets us because I'm pretty sure I won't do it from the first attempt. These tasks are pretty tricky for me. Okay, so yeah, let's create, I don't know, n and m. So n is the amount of rows. Oops, and n will be the amount of columns. Okay, just not to do always these links, and then we do just two loops. One is for rows, another for columns. And we are starting doing the stuff. So I guess it's just so we start iterating. First we take the first row and we go through every element in this row, all the columns, and I think so if this element, if grid ij equals to 1, so meaning that it's Earth, we start exploring. So let's create this function, traverse, or maybe explore the island. And what do we need to explore? Yeah. So first of all, let's maybe create a counter for the islands. So ctr, because in the end we need amount of islands. So at first it's 0. And when we stumble upon some land, we can be sure that it's an island. We just don't know its size yet. So let us update the counter, and then for while we explore. So what is the what is the goal of exploring? So while exploring, we want to visit all the elements of this island and kind of cross them out, so that next time we get to these points, we don't count them as new islands. So that's the goal of it. And so I guess as input for this explore, we need to know where it's happening. So these coordinates, so ij, and also we need to pass maybe some metrics of how it's called. Let's call it visited. Visited. So visited is the matrix which contains all the cells where we already have been. And yeah, I guess it should be enough. So visited. So visited is the, let's introduce it as an empty dictionary or a hash map, as you call it in general. And maybe we do something like this. So when we iterate through the whole elements, we say, so if this element equals 1, and also if we haven't visited before. Because if we already visited it, we shouldn't go and explore its surroundings. And not visited. And let's say visited will have the keys in the shape of this. So this will be a typical key. So let me put it in here. This one, so yeah. So meaning, yeah, we iterate and we say that if this element, if the current element is 1, so meaning it's a land, and also if we haven't visited this exact element yet, then we start. Then first of all, we say that it's a new island. we update our counter, and then we explore the surroundings. And the goal of this exploration is to populate this visited array with all the length elements. Yeah. Okay, then, so this function, I guess it shouldn't return anything. So the goal of this function is to update in place this dictionary. So let's create this function. Actually, we can put it in here. Def explore. And as inputs, it will have input. Yeah, for now pass. So yeah, let's say if we already have this function, after every iteration, we know we counted the island, we explored all the island elements, and I guess that's it for the loop. It's just in the very end, so we can return these CNC islands. Oops, let me just copy it. I guess it should be enough. So what we now should do, we have to create this function of exploration. Yeah, that's the most fun part. So as I said, it's kind of a breadth first search. So we are currently in the cell ij, so I is a row, j is a column, and we want to go to all possible directions. So I think, yeah, I mean, of course, I remember the idea of how I did it. That's why I'm kind of reusing this idea. So we introduce these all possible directions. Let's call them steps. And it will be an array of 4 different variations, because we can go left, right, up, down. So let's create all these 4 small steps. So first will be left. Left is we decrease I -1 and we keep j the same. Then let's go right. It will be I +1. And then let's go up. It will be j -1 and I is the same. And let's go down. It's j +1 and I is the same. So this is the set of all possible movements from the current cell we can do. And now let's kind of try to do these movements. So we iterate through the steps, like for steps. Oops. And first of all, we need to be sure that we are not out of the grid, because if we start, for example, here, we cannot go up and we cannot go left, because we will have an error. We will try to retrieve the element from the array, which does not exist. And for this, we say something like our I should be more or equal than 0 and less than our amount of rows. Because yeah, if you have 5 rows, your rows go from 0 to 3, 0, 1 to 3, meaning that you will never reach number 4. So, and the same should go for j, but for j we have amount of columns. So if this, if it's okay, if these conditions are okay, we can proceed. Otherwise, I mean, our function step. Yeah, otherwise we don't explore this step because it's impossible to make this step. Okay, so we make this step, and what we do. So let's say we're in here currently, and we did a step to here. So what's our goal? Our goal is to explore all the island. So if it's 1, we need to continue exploration, but already from this new element. So let's start. So if this new element, if grid step, yeah, it's a bit ugly, but now I need to do like this. If it equals to 1, so if it's another length, we kind of do the same. We we explore it again. So we kind of run the function recursively. So we run the same function, but for the new cell. But also we need to utilize visited. So I'd say that if we have to use two conditions, so if the cell is the length, and also if we still have not visited it yet, so something like this again. Oops, step 0. We don't even need this. We can say just step. A step is already a tuple, and step not visited. Then we do the exploration around this new cell. I'm thinking, is it enough or is it not enough? So we create 4 directions. We then try to go in every single direction. If it's still within the grid that we have, we check whether this cell is a length and whether this cell was visited by us before. So if it wasn't, we start exploration from this new cell. Yeah, so I forgot to update the visited, right? So that's the most important part. So maybe we can do it in the very beginning of this function. Yeah, so because so when we run this function, we start the exploration of this cell ij, so this cell, and maybe the first action that we should do is to say that, yeah, we already visited this ij because we're currently there now. So I guess we can add the yeah, I created kind of a dictionary, but okay, let's keep it a dictionary, whatever. So let's just say ij and equals 1. I don't know, yeah. So let me change it a bit. So first of all, we probably put it in here. So our visited will be not the hash map, but a set. I don't know if a set like is a construction in Python which contains unique elements. So you cannot put the same elements into this set. And I mean, there is just no value, so only keys kind of. And because we don't need keys, and for this I will just change it to add. Yeah, visited, and then here we don't need to check because it's still the same. It will work both for key for dictionaries and sets. Okay, so let me try to go maybe through it. Key. So again, I'm just checking this exploration function. So we want to explore the cell ij, and we also have this set of visited cells. So first of all, we add this ij to visited. It's already
is the
here.
ij in parentheses kind of array? Is it a pair? And I'm not familiar with this Python syntax.
So this is like so that's the parentheses for the method, and then we want to. So my unique element in this set is this. So visited elements are like this. So every element is another tuple, kind of. So that's why.
So it's a tuple. It's like a pair. Okay.
Yeah. So that's why I put it in there. Yeah. So we. Oh, actually, can I have tuples? Yeah, they are not. They are immutable. Yeah, because in set I can have only immutable stuff. Yeah, it's like. All these things for this. Yeah. So we add this current cell to visited. So next time we won't even try to traverse it or to explore it because it's already in the visited area. And then we create 4 directions or 4 steps. Then we try to iterate for every direction. first of all, we check whether this direction is still within the grid, so we're not out of the grid. And if it is within the grid, we check whether this new direction is the land, and also if we already haven't been there. So if we are not, so if it's something new for us and it's a land, we keep exploring from this new element. Yeah, and so the goal of this function is to update this visited set of visited, so that for the next iterations we won't explore the cells which are already in there. And let's go back to the mains loop of our function. So yeah, we create this counter. We start iterating through columns and rows, or rows and columns. And we check, so if the current element is the land, and also if the current element hasn't been already visited by us, then we say it's something new, so it's a new piece of land. We update the counter of lands, and also we start exploring this island. And after all these recursive runs, it should be the state that all this new island is explored. I hope.
Yeah, things make sense. Yeah.
Yeah. I don't even know even how to kind of manually debug it. So I guess I will just run the code and see where I did do some bugs, because let's see. Okay. Yeah. This is a bit weird. So it says that I didn't even find the first island, which is super weird to me. So yeah, these are the strings, not the numbers. Okay, they are the strings, right? Yeah, so I have to compare with strings of one. I hope that it's a mistake, because otherwise, am I comparing it somewhere else? I guess not. So let's see if that's the mistake. How to debug this stuff. Yeah, okay, so good. So ran okay for our one element, but I'm not sure if this recursion is kind of very optimal, because recursions can lead you to rabbit holes. I don't know. But honestly, I don't know how to implement breadth first search without recursion in Python, at least. Yeah, so I know only this way. So I guess we can just try to submit it, or Alex, you can.
Yeah. No, I don't have suggestions. I mean, you can improve some code, but that's fine. I mean, for this exercise, it's not optimal algorithm. Like, I think it's it's fine. Maybe it can be optimized, but not with something very easy. Yeah.
Yeah, let's. I mean, one thing which I would optimize is like using these tuples, because this looks very ugly, like a lot of curly braces. But yeah, let's maybe not do it for now. So let's try to submit it, and I just runs before. Oh yeah. Okay, so we got an error which I tried to avoid, but apparently I did not. So it says list index out of range. That means that at some moment in here, we kind of stepped out of our initial grid, which I really try to avoid by this. And let me see what was wrong in here. So ij is our initial cell. We create all the 4 directions. I think the directions are correct, right? Left, right, up, down. And then we check this. So the very left top element is 0, 0, right? So, and it will be okay in here. So if the element will be -1, then it won't pass through this conditions. So minus, I guess, is okay. What about the right side? So if we are trying to traverse element number, so in this case we have 4 rows. And what if we're trying to traverse row number 4? So if n equals 4, it should not go into this cycle. I'm a bit confused. What did they miss?
Yeah, you of course know much better. So this 16 line containing AND operator, is this priority-wise correct? Like you have two comparisons and operator as well?
Actually, I don't know. But we can try, yeah, as you say. Yeah, you may be right. If okay.
And in Python, you have this ternary comparison operator, like less than equal, and then I is also less than n, but greater than 0. That is a valid thing in Python.
Yeah, it's like, I don't know, syntactic sugar or how it's called.
Nice.
You can write it. Yeah.
Looks good.
Yeah, let's try to submit it once again and see. No, not really. And so submission details. It usually shows last executed. Okay, so no, it wasn't any edge case. It was a normal use case. Okay, let's go back. List index out of range. Well, it's so weird. Steps. Wait, of course. Why am I checking I and J here? Right. Yeah, so here I have to check like step number 0 and here's step number 1 because ij is the initial argument of the function. Yeah, so here will be step 0 and here's step 1. Okay, yeah, that makes sense now. So let's just run the code. It should work again, I guess. And for submit, at least it should be a different error now. If it's an error. It's super slow. In the lowest 5% of people who submitted did it.
Really? Okay. Interesting.
Yeah, success. Yeah, so yeah, our code is faster than 5%, so I mean we are bad. But yeah, actually I'm not sure how to make it faster, honestly. Because we are kind of using the hash of visited. Yay. Thank you, Kumar. Yeah, honestly, I have no idea for now how to improve it. And yeah, I'm also aware of the time. Maybe you can make the second task if I'm efficient today.
So yeah, I was wondering if we can make it a little bit faster too. I also don't know where to start. Maybe I don't know. Do we want to spend more time on that, or jump to another exercise? What is the best for you?
I would probably jump to another one. I just want to say that I kind of like these kind of tasks when, I don't know, it's called graph tasks or breadth first search tasks. I find it interesting how my brain tries to understand this recursion and that you try to explore the surroundings.
Graphical, or how what is the term?
Graph. I mean, I guess maybe it's not a graph. No, probably it's not a graph. Maybe just like breadth first search task.
I see greedy tag in some classification. Maybe this is a word, I don't know, but I mean
Maybe.
it's yeah.
Yeah. Yeah, what we did, we kind of did a greedy approach. So when we see something, we just start going into this direction and we explore it to the end, and then we go to the next one. Maybe there is more optimal solution. But yeah, I suggest we move to the next one.
Okay. Medium or easy one, what do you prefer?
I don't know. I usually, so there's this percentage of acceptance. So I try to keep it like from 40 to 70, let's say. If it's because easy and hard and medium, they don't really represent the complexity, but this exception rate it does. So what is the exception rate of this task?
I don't see it in this interface, but
No
let's
worries.
find out. It's
Yeah,
let's
no
try
worries.
something different.
It's higher rank. Okay, it's a bit different. Let me copy it. Let's wait again. Cloudy day. What could it be? Oh my, such a long.
It's
Yeah, let
huge
me log in.
description in HackerRank comparing to LeetCode. Yeah,
Yeah.
you can type escape, I think, and
Oh no! What the? Maybe I logged in with. Yeah, just. Oh, can I run without being in?
yeah. I think you can just close the pop-up. Escape works for me. Yeah.
Okay. No. Oh my god. No. Oh yeah, it will take some time to read it. Quibdó in Colombia is one among the cities that receive. What's happening in here? Do you also see it shaking? No.
Yeah.
Okay, so yeah, Quibdó in Colombia is one among the cities that receive maximum rainfall in the world. Yeah, it's a lot of rain. Oh, let me put it in here so that we can read it first. All year round, the city is covered in clouds. The city has many towns located in a one-dimensional line. Okay, so city consists of towns. The positions and populations of each town are on the number line are known to you. Number line, okay. So every cloud covers all towns located at a certain distance from it. A town is said to be in darkness if there exists at least one cloud such that town is within the cloud's range. Otherwise, it's said to be sunny. Okay, so I guess we have two kind of areas. One represents cities and one clouds. Okay, city council determined that they have enough money to remove exactly one cloud using their LeetCode. Yeah, thus they want to remove the cloud such that the fewest amount of people are left in the dark. Yeah, so we want to remove the cloud which is more efficient to let more people see the sun, I guess. And the question, what is the maximum number of people that will be in a sunny town after removing exactly one cloud? Yeah, that's interesting. So if town is not covered with any clouds, it's already considered to be sunny, and the population of this town must also be included in the final answer. Okay, yeah. So complete function maximum people, PXYR. So which takes four arrays representing first this population, P population, locations X are locations of towns, Y are locations of clouds, and R are the extents of coverage. Oh my god. Yeah, so it's kind of the length of the cloud, kind of. So there's some example, I guess. Yeah, I mean, I kind of understand. Yeah, I kind of understand. Yeah. So yeah, population. So every town has some population, the positions of these towns, the positions of the clouds, and the lengths of the cloud. Yeah, that's a cool one. return the maximum number of people
Different
that can
level,
be
you see.
send it down. Yeah. Oof. Okay, where to start? I mean, I guess we can eliminate the edge case where there are no clouds. Uh, clouds, and it will be the no clouds, right? And separated integers. First one contains constraints nm. What is nm? Do we know nm? Okay, and integers. Oh yeah, okay, n towns, m clouds. Okay, so there's at least one town and at least one cloud. Okay, my edge case didn't work. Yeah, I mean, first of all, I guess we need to iterate through all of this to understand how many people are covered, how many people see the sun and how many don't. I guess we can do it in one iteration through the towns, or kind of in one adjacent iteration through both clouds and towns. Yeah, maybe it makes sense to create kind of a I don't know, a dictionary, or whether a town is covered by cloud or not. So it will be the first step. Create a dictionary with key with a town as a key, and cloud, and I don't know, sun cloud as a value. So let's say, I don't know, 1 will be the sun, 0 the cloud, or the other way around, I don't know. And then we need to find the optimal cloud to remove. And this, like, even the first is a bit challenging, but the second will be even more challenging. Yeah, let's try to create at least the first part. So P is towns, X, P is population, sorry, yeah, we don't, P population, X is towns, Y is clouds. Okay, how to better create this dictionary? Are they at least sorted, these guys? I mean the X and Y. Where's the complete function? Locations of towns, locations of clouds. Are these locations sorted? Integers. The next line contains n space integers, denoting the location of ice town on the one-dimensional line. So they don't say anything about being sorted. Yeah. Next line consists ice cloud. Note that this range of each cloud is computed according to its location. Yeah, minus length plus length. Wait, it's kind of half of the length. It covers every town within a distance r from it. Okay, yeah, so yeah, weird. Air is kind of a half of a cloud, not a cloud, but whatever. Print some out explanation. In this case, there's just with solve cloud. Yeah, okay, I mean, they don't. So what I want to do, I want to iterate towns, and I want to see how they are covered with clouds. So, I mean, this is like a task of combining two intervals. My favorite one. Let's say like interval 1 and interval 2. Bum, 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 bum. So left, right. My head is not working. Well,
I can hear how is it working, like cranking, a little bit cranking.
yeah. So yeah, I mean, let's first of all sort these guys because I don't know. Sorted. Yeah, it already makes it n log n, which is super bad. But for town position in sorted x. Wait, then I have to sort it all together because I will lose the consistency between the errors. Man, maybe it's sorted because even this. Let me just hope that it's sorted for now. Because otherwise I have to sort like both
correctly, that's one cloud covers all the city, like all the population in the city, something like that, or?
Yeah, as far as I understand.
Or not?
Wait, the city also has a length. Wait, in
It has
case,
location. Yeah.
Yeah, I mean, currently location is 5, I guess. But the width of the city is also 1. This one I didn't get, honestly. Cloud presence location 4. Range on the number line and has a range of 1. So it covers towns located 3, 4, 5. And the town is covered by this cloud. Cloud makes it so. No, I guess the town is kind of located directly on 5. They just drew it so that it's also at 4 and 6. But the cloud is located, yeah, its center, it's on 4, and then we go r left and r right. So in this occasion, r equals to 1, so it means that the length is 2, and it covers all the towns from 3 to 5, meaning this town.
The whole town.
Yeah, I guess you covered the whole town. Yeah, okay. Because town is like doesn't have second dimension, so it's only a dot on x-axis.
So we sort of need to find all the covered cities by clouds.
Yeah, I mean, let's maybe let's maybe do it like a very stupid way, like iterating through all the clouds for every town, because of course it should be done smarter, but let's start from somewhere. So for cloud in y, and if wait, where's r as well? Yeah, okay, so we need to iterate also its range. So we need to do. Oh, HackerRank doesn't know this. Okay, we do kind of a zip of 2 elements. So y is the position of the cloud, and r is the length of the cloud. And cloud position, cloud radius of it. And if town position not in. So the left side of the minus cloud radius. Yeah, okay. So let's check the left side. Is more or equal to the left side, and down position is less or equal than the right side, then this down is covered with the cloud, meaning that yeah, we also should know which cloud it's covered by, right? Not just is it covered, not let's create something, some city like town by cloud. So it will have the position, or maybe yeah, maybe let's iterate through two arrays. X is the city and position, so position and town population. So as the what we save as a key there will be a population of this town, and as the value will be the ID of the cloud. How to put the ID of the cloud? Just the position of the cloud will be enough, right? Because it's unique, I guess. Cloud position. Or not? I guess there shouldn't be clouds in the same position. Not there. No, I actually don't say that. So there could be clouds in the same position. No, that's a good task, Alex.
Yeah, sorry for that.
No,
There's a lot of rain recently in my town.
yeah, yeah. Town population, cloud position. Is it unique or not? I mean, they don't say anything about being unique. Well, let's hope for now that it's unique. I don't know, because we already made a couple of, I'll call it not suggestions, but guesses. Yeah, I probably didn't do it right. I always forget how to do it like this. Yeah? Okay. By the way, yeah, I'm not sure about these priorities, so just in case. No, it should be good. Okay, so now we know. Now we have the dictionary which says that this population is covered by the cloud. Yeah, actually, let's maybe create another one. So in case we don't go to this if, so meaning that, meaning after we iterated through all the clouds and we didn't find the, wait,
Cloud
how we
that
will,
covers the town.
yeah, but how we will know that we didn't find? Maybe we're breaking here, yeah.
You know the simplest task when you find the biggest number in array. Basically, you remember the element and compare it like the biggest. If it's bigger than the current one, then you apply a new value to it.
Yeah. Oh, actually, you're right, because there could be multiple clouds covering the city, right?
But you need just one.
Do I?
You need the biggest one.
Because when we will most efficient, but how will I do? I'm not sure if we need the biggest one, because there could be like a huge.
Yeah. I mean, the
because
one that covers the most population, right? This is a task.
Yeah, but at this stage we won't know how much population is covered because we go town by town. So
and cloud can cover multiple towns.
Yeah, and for now we won't see it. So maybe it's better to go via clouds, actually. So let's think. So if we go yeah, maybe we go through clouds. Yeah, actually, it's a good idea.
Mm.
Then let's call it cloud by town. Whatever it means. Yeah, let's go through first this. So we iterate cloud and its radius, then for every cloud we iterate through all the towns. And then the same, so if the town is under this cloud, we cloud by town, and this exact cloud, so we get cloud position. Yeah, and we just add up the population, right? So town population. And for this, oh man, we cannot do like this. Yeah, because can we import? Can we use additional library for this? I guess we cannot. Right? Okay, so if we cannot, it will be something like cloud position equals to because if the element in the dictionary doesn't exist, it will throw us an error. So we will try to get this element, and if it doesn't exist, it will be 0, and then we add town population to this element. Yeah, maybe I do like this. Yeah. Okay, so we update this cloud by town. Now we don't need a break. So after the end of this double loop, we will have the dictionary, which will tell us which cloud has most of the population. Oh, now perfect. Yeah, and now we just have to sort out a dictionary, right?
And you don't even need to have this anymore, right? If you save intermediate calculation, but that doesn't matter. I mean, that can be optimized later on.
Actually, you're right. Yeah. So, but yeah. Actually, maybe create I don't know, toughest cloud.
Yeah.
For now, it has a population of I think it's how it's called, float. So toughest cloud. Yeah. So we start from 0, toughest cloud. But what we have to we output the ID of the cloud. What do we need to do? Print
yeah, something like that.
Number of people. Yeah, number of people. Okay, number of people.
Number of people.
So yeah, toughest of cloud. So we need to know the initial amount of people. Population P. Like if we do something like this.
It says something strange. It says a maximum number of people that will be in a sunny town by removing exactly one cloud. What that means, I'm wondering if a cloud covers multiple cities, for example.
Yeah, it does.
Weird.
No, I think like in the beginning you have like towns covered with the sun and towns not covered with the sun. So let's say 5 there, 5 there. Then you remove the cloud and 3 towns are not covered.
Okay.
And you sum them up to all that were already not under the sun.
Yeah. So we are on step 1 when we trying to remove a cloud first, right? And then we figure it out what's left with the sunny town.
Yeah, and actually you're right. So here we iterate through the towns, and we kind of need to remember how many towns were already not covered by the sun, because we will need it in the very end. Because we will need like the delta, how many will we kind of free from the clouds, and we also need to know the initial amount of already free people seeing the sun.
We can save towns that we gonna free by killing the toughest cloud, right? We can save them and then compare in a second loop if that's make a deal.
Yeah. Yeah, I mean, in this case, we will need it again to loop through all of these guys, right?
Yeah. But that is possible, yeah, but not necessary, of course.
Yeah, but I'm just thinking whether it's possible in here or not really. So Yeah, here not really possible because we need to iterate through the towns first and then to the clouds. Maybe actually, yeah, we need both of them. So here we kind of map the clouds to the towns, and here I just put back. We first iterate through towns and then clouds, and now.
I mean, sorry, actually, that is an interesting task to solve together. I mean, you can also add an else in a previous loop and say, okay, if it's not covered by any cloud, then I can also count like a maximum town with maximum.
Yeah, I agree, but in this case, I won't know that if the town is not covered by any cloud because I iterate first through the cloud.
Yeah, and then you can
by town.
decide to kill it. Yeah. Mm-hmm.
Yeah, so I want to do this in here kind of. Yeah. So yeah, I want to do like we iterate through the town and then for all the clouds, and if it's covered, then we just break from this, meaning that we go to the next town. But if we iterate for the but what the hell? But if we iterated through the whole set of clouds for the town, then we say that this town is not covered, and then happy people, happy people, and then we have happy people by this town population. Yeah. So I guess in the end, these happy people will be the amount of people that already have the sun. And here we, here we need to know the max element of this array, of this dictionary. Actually, yeah, toughest cloud. So toughest cloud, give this position. You're right. After we do the whole towns for this cloud. So here, if toughest cloud, let's say if current cloud is more than toughest cloud.
Yeah, but Igor, I think. Well, first of all, I think we can do it in a one loop still. Second, if you look at the output format, it says, I think, the biggest town, sort of, the biggest populated town with a sun. So it's not all the people, not all the happy people, but happy people in the biggest town, I think.
Yeah. Okay, let's make count. Okay. Remove the clause such that fewest number of people are left in the darkness. What is the maximum number of people that will be in a sunny town after removing? Okay, so you're right.
It says a single town. That bothers a little, right? Because cloud can potentially cover multiple towns.
Mm-hmm.
But that allows us actually to do it in one. So that's good.
Yeah, you're right, I guess. So yeah,
so we know the toughest cloud, and then we can count on the iteration which one is free from clouds. And sorry, it's your task.
Yeah, but also we need to have like the biggest town, right? Biggest happy town. Let's say.
Yeah. I think indeed we need to store two numbers in the iteration, like biggest sunny town right now, let's say, and then the if inside a loop will calculate what do we make more people happy, let's say.
Yeah. Okay, yeah. So that if it's but again, how we will know if it's sunny?
So we track the biggest sunny town. We can do that by each loop, right? If, for example, the town is not covered by cloud right now, we just know that this is amount of people that are happy right now. And then if it's covered by rain, then we need to make a decision: do we kill it or not? And we don't kill it yet, but we store this number, and in the end we just kill the cloud with the biggest coverage.
Yeah, but then we need to track like the second biggest town when we, because we kind of iterate first through the clouds and then through the towns, and then if we see that this town is not covered by this cloud, but it was covered by the previous cloud, then we kind of need to store all these elements. So I guess like I will just, I think for me it will be just faster if I do it like this. So biggest signed town. So we iterate through the towns and through the clouds, and if there are no clouds, we just say biggest signed town equals max of biggest signed town.
By the way, we are out of time.
Just a sec. Yeah, we're out of
Yeah.
time, honestly.
Mm-hmm.
Yeah,
That's
let's
a
just
super
stop
nice
this
exercise.
suffering. Yeah, but it's a really cool one. It
Yeah, I
looks
think
more
we
scary than
almost
it is,
did
I
it.
guess.
I mean, yeah, first it looked difficult, but we almost went it. I think through it. Yeah.
Yeah, but it's a cool
Igor,
one.
does it
Thanks,
help
Alex.
to solve these tasks in general? And do you feel like you get into it?
Honestly, I think it does. I mean, does it help to solve in what? I mean, it helps to quicker solve them. I'm not sure if it's anyhow applicable to any aspect of working life. So I don't think it's anyhow connected. So it's just like a separate thing. If you like doing LeetCode, or if you wanna pass interview, which includes LeetCode, then it definitely helps. So I don't know, 1 year ago, I was like much worse. I couldn't do any of these tasks, especially first one. I will just stumble and cry. Now I could do it. But as you see, I'm not very fast and efficient, so there's definitely
Yeah,
ways
that's
of
fine.
improvement.
I mean, you are not a student right now, and they're not doing the Olympic challenge, so
Yeah,
it's cool.
I don't want to be the one.
Mm-hmm.
Yeah, but it's definitely trainable. So if someone
Mm-hmm.
wants to do
Mm-hmm.
it, just do it. Do it.
Yeah, do it and have a good Saturday.
Totally. Yeah. Thanks everyone for joining
Thank
and
you.
watching this. Yeah. Thanks, Alex. Cheers. Have a great weekend.
Cheers.